welcome on stage Eva Sarafianou from Mattermost, where she leads the product security and security research team. And well, if you're part of the CERT network or you are using communications as an open source software, well, you most likely have been using Mattermost, right? So this is what we use at the National CERT. I know that other CERTs use as well. So please, Eva, the stage is yours.
Thank you. So, hello everyone. Thank you for taking the time to be here today. We'll be spending the next 40 minutes discussing everything from report to disclosure. So we just heard the first part, all the great things that researchers do, but the question is, once we receive those reports, how do we handle them? Before we get started, very briefly, I lead the product security and release engineering teams at Mattermost, and I was previously at Okta as a principal product security engineer. It is important to briefly mention what Mattermost is because this influences how we've designed our vulnerability management program. Mattermost is a secure collaboration platform, and it is for mission-critical work. So our audiences are mission-critical operations, defense, and DevSecOps. So from this, you can understand that our audience, they have high security standards, stringent security requirements, and we need to take this into account when designing a vulnerability management program. Mattermost is also built as an open core platform. This means that the vast majority of our code is open source. And while open source code has great benefits when we talk about the fact that the code can be audited by anyone, it does have some challenges when we're talking about vulnerability management. So in a very high level, what are the different stages of vulnerability management? It should be pretty obvious to most of us here. We have an intake, we triage the report, we start fixing it, we release the fix, and finally there is a disclosure part. This should be similar in most organizations, maybe with the exception of the disclosure. This is something that closed source environments don't do. But when you think of open source or open core, you need to tell your audience of vulnerabilities so that they can upgrade. And there is something more that Mattermost is also offered as a self-hosted instance, which means that customers who run Mattermost in their environments, they also need to know if a new release that comes out contains vulnerability fixes or not. It is also important to be clear when designing the program on what are the responsibilities and how they're split. And usually, security takes care of the two ends of the process, so intake, triage, and finally the disclosure. Engineering usually works on the fix and the fix release. We will cover each of those phases separately, but before we do that, we need to think of what a good vulnerability management program looks like. And this will drive what kind of metrics we want to have. The way I usually approach this is by finding what kind of questions I would like to be able to answer. What's the severity of our vulnerabilities? So the trend we want to see is less highs and criticals and more lows and mediums. So we should have a metric saying that over time, the percentage of highs and criticals gets decreased. How many vulnerabilities are we resolving every month, and how many are introduced every month? If you combine those two questions together, what you want to answer is, are we trending towards a never-increasing amount of open vulnerabilities, or are we trending towards zero? Like, if vulnerabilities keep increasing, we need to take some sort of action. What types of vulnerabilities affect us the most? If we have access control and authorization issues being our top one, we should take some action there. It can be additional training for our engineering teams. It can be using our static analysis tool to write some custom rules specific for how we design authorization internally to catch those better. It can even be a policy saying that if you're touching endpoints and touching permissions, you need to let the security team know to review. Are we hitting our SLAs? There is no vulnerability management program without SLAs, and there are no true SLAs if we don't measure them. And again, the trajectory is that the SLA hit percentage is getting higher. There will be times, though, where SLAs are not met. And to answer the why and how we can improve, we need to know in which stage of the process the vulnerability takes the most time. So did we spend too much time in triage? Was it in fix? Or where was it? So some data there will be helpful. Let's start with the report intake. There are usually two important things that you need to know. One is know where to expect vulnerabilities to come from. It can be from bug bounty programs, public or private. It can be from a VDP. usually both of them are handled by a third-party vendor. The difference is that VDPs don't pay out researchers. It can be a customer of yours. It can be internal, like your engineering teams. It can be an email. Usually organizations have a security email or a responsible disclosure email that we also need to monitor. It can be your annual or semi-annual pen test. Whatever the list is, it needs to be clear and it needs to be monitored. And the question is, by whom? And when I say whom, I mean a specific person. Every time the responsibility is a group responsibility, I'm not sure there's real responsibility there. So 2 options. You can have a dedicated person. It's always the same person making sure that new reports are getting handled. Or it can be a triage rotation. And the latter is what we do at Mattermost. We have weekly rotations. So each week we have a specific person responsible for handling that. And because we don't want to remember when is my time, we actually use PagerDuty. We have a triage calendar there, and we get notified when each one's triage starts and ends. If we go to the triage phase, first of all, we need to reproduce behavior. And one of the things we need to do there is identify if we have any specific configuration that is required. I'm very purposefully using the word behavior and not vulnerability. Vulnerability is a statement that we need to assess whether it is or not. So for now, we just need to make sure, is what the reporter is saying reproducible for us as well? And then we need to answer the question, is it a vulnerability or not? And to answer that question, I will not comment on the false positive because this is pretty easy to tell, but there are some additional questions to answer. Is this a vulnerability or a security enhancement suggestion? And I'll try to explain how I differentiate those two. If you have a statement saying there's a CSRF vulnerability in that endpoint that allows me to do X, Y, Z, this is a vulnerability. It is exploitable in the system today. If you get a report that says that a user can perform sensitive operations without step-up authentication, so without requiring authentication, I will most likely classify this as a security enhancement. Every software can become better in terms of the security within the product, but the reason I want to differentiate them and be very strict on what I classify as vulnerability is because I want to have a very strict vulnerability management program. It is one where we partner with our engineering partners to make sure that vulnerabilities take priority over other work, and to do that, they also need to understand the importance of it. If we start sneaking in like security enhancement, I think we start losing the trust that we need and want to build with everyone we're partnering with during the vulnerability management process. The other question is, was this a design decision of the past that we now view as insecure? And what I mean by that, it's possible that 5 years ago, we designed a feature in such a way that we viewed as secure. Threat landscape changes, the risk appetite of an organization changes. So the fact that we decided like that before means nothing. And we can handle this as a vulnerability too. So we can have code implementation misses or deliberate designs that are now viewed as not secure. And finally, we need to do some root cause analysis. We've found it recently very useful to use AI tools for that. So if you give the vulnerability report and then the source code, it is usually quite easy for AI tools to pinpoint where the vulnerability is and walk you through the whole attack flow. Again, you need to check your AI policy in your organization to see if this is allowed for you or not. So once we've done that, we can start to kick off the vulnerability management process. There's usually some sort of a ticket creation. We have reproduction steps so that engineering teams and our security teams too can reproduce it too. Some suggested mitigation that comes out of our root cause analysis. Severity or risk, and this will influence our SLAs. And finally, we need to collect some data to drive our vulnerability management metrics. Now, you see here saying both severity and risk, and I want to discuss a bit which one to measure and when. Severity measures the impact without taking into account the environment in which the software runs. On the other side, risk is environment-specific, and it maps better to an organization's threat model. So I may have a vulnerability that is high, but there are compensating controls in the specific environment that lower the risk. There can also be a policy of an organization saying that internal services I consider them less risk. So the same vulnerability, if it moves to an internal system without internet access, then the risk is lowered. Now, In the open source environment, we don't know where our software runs. The code is out there for anyone to use, and this is why we need to measure severity in open source software, which is actually taking the worst case scenario of an environment with no compensating controls that just this software runs and nothing else. Let's go to vulnerability fix implementation. What are the risks in fixing vulnerabilities in open source repositories? And how could we possibly minimize those risks? I'll bring an example, and I'll read that for those at the back. Look at the title, restrict guests from reading public channel posts. Look at the description, it's even more detailed. It says that a guest user was able to read a public channel post from a channel they were not a member of from a specific endpoint, so this PR restricts those permissions. Even the commit says the same. This PR is perfectly fine if your repository is closed source. It gives all the details for your reviewers to go and review it perfectly. But if we think in open source, the moment you push a PR to fix the vulnerability, you've also disclosed everything. Does this look better? It does. We've updated the title, the description, the commit to be high level, like update guest permissions. We may be updating guest permissions because there's new feature being added, and we need to update permissions. It can also be a vulnerability fix. Are we safe? No. The code is still there. Like, anyone can go, check the code, and possibly identify what is the issue. It really depends on how complex is the issue. If it's 2 or 3 lines code, it is very easy for someone to understand what was the behavior before and why you possibly are fixing it. In more complex scenarios, then it may take more time, but still, the code fixing the vulnerability is public. So with that, it is important to always know that the time between a PR push, a fix push, and the final release, there is time where some amount of vulnerability details are disclosed. There is an alternative, which is we could be using private forks in GitHub. In this case, all the collaboration during the review phase happens in closed source, and then the final code becomes available after merge. Now, it's not that we saved all the time, but yes, we reduced the time, like the time between PR push and PR merge. Now this happens in closed doors. Whether we go that route or not really depends on the organization, because private forks come with some operational burden, like creating the fork, inviting each one specifically, and so on. So it is a balance that it's up to each organization to decide whether to go that route or to. And finally, as security professionals, it is important to review that fix. I'll go back to what I said in the beginning about we've done the root cause analysis, we suggested some mitigation. Let's go back and check that they did it correctly. Engineering teams are not security professionals. And finally, let's include tests to prevent regressions. What we don't want is a month, a year further down the road, someone adds some new capabilities, and without realizing, they reintroduce the vulnerability. So having tests would catch this and would prevent regressions. If we go to disclosure, we need to give sufficient time for both customers and end users. We need to have time for them to upgrade before we release more details. And in order to be able to do that, we need to document the process and publicly. So we need to be transparent to vulnerability reporters who want to know when they will be credited for their work, when can they blog, when can they have a CV on their name. At the same time, we need to be transparent to our customers. How much time do I have to upgrade before vulnerabilities details are out there? What we do is that instead of fixing just on the next minor release, we also fix on all the supported versions, like with a patch upgrade. And this helps customers and users not have to have a minor upgrade, but just a patch one with a vulnerability fix that is usually more easily justifiable within different organizations. And we are a CNA for our own CVs, so we control reserving our CVs and publishing those. But another thing that we are doing is that we have a page called Security Updates, and we also disclose vulnerabilities there. It's pretty much the same details as in the CVE file, which is what are the affected versions, what are the fixed versions, the severity, and then some details on the vulnerabilities. And what this offers is that end users and organizations can actually subscribe to those updates and get notified when there is a new release that contains vulnerability fixes, and so they know, well, we need to go and upgrade. We have 30 days between vulnerability fix and disclosure, so within those 30 days, organizations using Mattermost would need to go and upgrade. I want to spend some time demoing a bit our internal process, and I'll give specific focus on how we've tried to automate the process. The reason is that vulnerability management is a very, very repeatable process. It's also quite manual, and I don't want to say boring, but you do the same things all the time, and like if we can automate that's even better. So this is our Jira workflow, and the reason we've designed it this way is that it maps to the different phases of the process. And so it starts with, like, in reviews, when we're triaging the finding, you get to fix development, engineering is fixing it. After merge, we move to release preparation, and we're preparing the releases. The reason we have release preparation is we're not just a SaaS, we need to actually prepare the self-hosted versions. And then we move to the CV preparation, which is after release and before the disclosure. Now, what this allows us to do is that we can enforce phase transition requirements, and this is how we make sure that we collect all the data we need for our metrics. So before you move to the next stage, you cannot do that unless specific vulnerability data are filled. And you can also trigger automation once you transition to different phases so that different actions can take place. So I know this is small letters, I'll explain. The next 3 slides are videos that walk you through the process internally, and I'll be pausing and explaining. So this is a vulnerability that came to us a few years ago, and it is a zip bump. Mattermost has something where you can have Kanban boards within Mattermost, and to do that, you can create them within the platform, or you can also upload a new board. So we need to have an import functionality. And the vulnerability was that in that import functionality, there was a zip file, and we were not checking the size of the compressed files within the zip file, which could turn into a zip bump, and that could lead to a denial of service or a crash to the server. So what happens when we first, as you see, or you don't see because it's very small, at the top we have a description, then we have detailed steps on how to create the zip bump, how to upgrade, and on the mitigation, they recommended, in this case it is, and this is Golang specific, it's just use a limited reader so you don't read everything. So let me hit here the play, and what I want to show is that this is a vulnerability ticket, and we have a linked bag ticket. This is what our engineering teams will work on, and this is automated. The moment we create one, the same details are copied over to the bag ticket, and we have a new channel created internally in our Mattermost, in our internal Mattermost instance. Another thing is, Mattermost has something called playbooks, which are, you can define repeatable processes, is what you see here, and we document all the different steps that we need to take in different phases. So it's the trias, and I'll scroll down in a bit, and you see investigation for exploitation, remediation, the resolution. And this is a channel where we are inviting engineering to work on and collaborate. Because we're open source, we cannot have all the discussions in public, so we have per vulnerability channels and playbooks to ensure that we collaborate internally before we push out the PR. The next video is, we've moved forward, the engineering teams are working on the fix, and if you see here at the bottom, there are three fields. Security update text, this is what we would, sorry, that's the next video, I'm here. Yes, so these are placeholders, and if we go, and we have reserved the CV here already, but if you go to the back ticket, you will see that the ticket has the same disclosure details. What we're doing is that engineering teams are responsible to document the CVE details. We will review them before the release, but they have all the context when they're working on the fix, and they are equipped to create the details. Now, what I want to show with this video is that there is automation where when the back ticket is moved from submitted to resolved, which means the PR is merged, we actually copy these fields and we paste them over to the vulnerability ticket. Now, why don't we just have them in one place? People don't want to change tickets. They just like their own ticket. They have their back ticket. This is what they're working on. They don't want to care about anything else. So this is why, like, you stay engineer, and the engineer will stay on their ticket, and we'll handle like copying over whatever we need with automation. Another thing that happens is that we played this. Another thing that happens is that we have automation in place that notifies our release manager, and you'll see this briefly, that the fix is merged so that she can start working on the releases. And again, it's our favorite bot. People don't like being told what to do by humans, but they do like if it's a bot one. And moving to the final one, which is we are releasing everything. We have released our vulnerabilities, and we are ready to move to the CVE preparation. You see here there is some automation where affected self-hosted versions are automatically added based on the fixed versions. But what happens is that once we move a ticket from release preparation to CVE preparation, we have automation that collects all the data that is within this file and creates our final CVE file and attaches it to Jira. And you see here like the CVE file. So what this allows us to do is, we as security team, we do nothing with disclosure before the day we need to do the disclosure and like review the details that engineer is put. Everything is automated. Like, we've filled the data, but we haven't gone ahead and created the JSON file. Another piece of automation, and again it goes back to people like bots, they don't like humans, is automating SLA notifications. So we have a midpoint reminder and a final reminder 1 week prior to the due date. And what the automation does is we can map between the team responsible for the fix and their engineering manager, so we can notify them when like, to have SLA reminders, both midpoint and like when the clock is ticking for the final due date. Closing, on addressing critical vulnerabilities, we still use the same process, but not exactly. And the reason is that critical vulnerabilities being critical, they need some sort of urgency that a normal vulnerability process doesn't usually help with. So what we do is actually we treat critical vulnerabilities as incidents. I found that incidents is the most well-organized process that is acceptable by the whole organization to bring everyone together now and to sidestep things like, but I have this feature to work on. It's okay, this is an incident. And so we can bring everyone together if it is an incident. It's the only way we can have a fix in 24 hours or 48 hours and have the buy-in from the whole organization that this takes precedence. So it is good to have time zone coverage. This depends on your organization. We are global, so what we're actually doing is that when the business day ends, then we have a handover to the next time zone, and this allows us to sort of work around the clock during critical vulnerabilities. And we also need to get buy-in. As I said, I can start pulling in engineers and like stopping them from other work, but it is good that the leadership knows this beforehand. So we need to get buy-in for that. And we need to document expectations. Incidents and critical vulnerabilities can be stressful when we need to identify the root cause, fix, and notify customers in like 1 day or 2. So letting people know ahead of time what exactly they have to do during this time, it helps make the process smoother. The final thing I want to share before closing is that vulnerability management is a shared responsibility. It is often seen as something that the security team owns, the security team handles, and engineering or other organizations help. And I don't think this is the best way forward, and this is why throughout the process we've created, what we're trying to do is to elevate engineering as our equal partners in this process. We can triage vulnerabilities, we can assign whatever risks and data we want there, but if engineering is not there with us to work on the root cause, to work on fixing the vulnerability, then we don't really have much progress and much success. So what I would like to close with is, let's try to make vulnerability management a shared responsibility within our organizations so that everyone sees the value of coming together, working on fixing those vulnerabilities quickly and efficiently. Thank you.
Thank you, Eva. I will open up the questions from the audience. If there are any, just raise your hand and I'll try to notice you. Okay, there are no questions so far. I have a few. So we as a national CERT and also as a European Union, we are introducing all of those vulnerability disclosure platforms where we need to process this. In your experience, how much vulnerability trolling, like when you're overflowed with useless vulnerability reports, you have that in your cases as well? And also you mentioned, adding to this, you mentioned that you're using the LLM as well in that process as well to dissect, like if the report and the proof of concept actually makes sense. Does that allow you also to kind of limit this trolling of vulnerability reports?
That's a very good question. So we're lucky to be using vendors that handle the incoming reports. I think 90–95% of our incoming reports come through our bug bounty program, which means that the bug bounty vendor can handle that load and protect us from these vulnerabilities that come and are not true positives. Otherwise, there was a time before that we actually had to handle. Yes, it is cumbersome, but what I've seen is that it's the same behaviors marked as vulnerabilities and reported all the time. What we had done back then is that we actually had an inventory. This is what they're reporting. This is our answer why it's a false positive. So we were trying to make it easy to not just type the same response over and over and have it ready there. That's the first question. And for your second question, I guess we don't use that. When we were treating vulnerabilities ourselves completely, AI was not where it is today, so we were not using it that way.
All right, I mean, I have a question about the timelines. So just a regular vulnerability resolution and the criticals, how long on an average would it take between the regular and the critical that you've assessed?
So our criticals have 2-day SLAs, 48 hours. And the reason is, I would actually like to have 24, if you ask me. But because we have self-hosted releases, there is some process around actually creating the final releases in all the supported versions that take some time. We also have a cloud offering, and we need to make sure that this is also patched together with our self-hosted releases. So this is 2 days. And then, yes, it depends on the severity. It's 15 for highs, and I think it goes to 30 for mediums and so on. We're trying to be strict. This is why I said earlier that I want to go through the vulnerability process only when something is really a real vulnerability, because we've managed to get buy-in for strict SLAs, and we need to be also mindful of what we add in that process.
Right. I will still look for the questions from the audience. So, now. Okay, you were first. Let's go here with the gentleman in front row, and then we have one more question.
Hi. Thanks for the talk. I'm not sure about internals of your product, but I believe you are using other third parties dependencies. Do you have a separate process when vulnerability stems from a third party?
I was actually expecting this question. We use almost the same process. So yes, we have the same process. There are a few differences there. There is no disclosure. The CV is already out there. It's not in our software. SLAs are a bit different, but not that much. So the main difference with third-party vulnerabilities is, are they exploitable in our software or not? And this is something that we have as a difference between the two processes, although they use the same Jira workflows and everything, which is there is a consideration. Does it make sense for me to go and spend time at understanding if this third-party vulnerability is exploitable in my system, or is it simpler to just go and upgrade? If there is an upgrade, usually that's the fastest route, and we often don't go through the route of identifying exploitation or not. If there is no vulnerability fix, and there are a few different routes there. What we're trying to do is contact the contributor. There are many times when we've worked together with the maintainer to create the fix and have the release ready. Another thing is, how can we change our code base to protect against that vulnerability, regardless of whether and when the fix will be available. To go through that path, yes, this requires that we've concluded that it is exploitable in our system, but at a high level to your question, it is mostly the same process.
Thanks a lot for extending answer.
Thank you. And the next question over there.
Yes, my question is, when you are fixing these vulnerabilities, do you have some kind of dependencies between the functionality in Mattermost? For example, this file size, if it's some dependent on the other functionality, how you handle these changes? For example, in financial world, we have a change advisory board who can approve these dependencies, or is it something like in the Mattermost world that when you're fixing the vulnerabilities, is dependent from other functionalities internally, and how you are dealing with these dependencies between the functionalities?
So I think one part is that we're not a really big org, and this helps with internal communication and collaboration. There are times when changing something will affect something else. This is true. And I think this is where small organizations are more quick and to address that. There's no need for an advisor. We just go and ask those people. We let them know, and then we find a middle ground. What you're describing, I've seen this in larger orgs, but not in ours.
All right. We have time for questions as well, so if there's anyone else. All right, for me, the question is, because you do offer the free community edition, which is pretty much most likely the one most widely used out there, but you also have the paid commercial version. Do the SLAs vary between those, or you just keep everything under the same kind of release and patch cycle?
No, it's the same. It is the same, exactly the same release process. It's just during our release process, there's the team edition, the enterprise edition, but they happen at the same time.
All right, with this, let's thank Eva once again, unless there's a last-minute question. No, let's thank Eva once again. Thank you.